new huge project. I just got this Generac. It's a 22K Guardian, and I'm working on getting ready to install this baby. I pulled a few things apart on it, mainly for my own knowledge, and I will go over how to take it apart. But I wanted to see a few things in here, and before I even moved it to its resting place. And it's very easy to take this stuff apart. But the next big step is I need to unbolt it from the pallet here, and then to get it back through that door, I borrowed this from a friend who does Generac install. So this is the dolly. I'll show you how to set it up. So like as you can see, those mounts, they have a long hole through there, and these rods are going to go through it. I mean, there's so many different ways to do it, even if you had like a pallet jack or something. But I need to go back here. So the one thing I was going to do is lift it with my tractor and swing it up over this wall and drop it down, which would have been actually fine. But being that my friend right down the road has got that the Generac generator dolly, I'm going to go ahead and use it. First problem encountered. Nice dolly. Nice dolly won't fit through my gate by about 3 inches. So my other gate over there, same thing, and then there's a second gate that it won't fit through. This way I got a double gate, but that means I'm going all the way around my house. So I can't fit it through here. What I'm going to do next, I'm going to drop it down on some pipe, unhook the dolly, roll it on the pipe, and then re-hook up the dolly once I'm cleared the gate. So next big thing on my list, I'm running the propane piping for Generac. I learned a few things here that are worth noting. I was actually originally going to put it over here because there was all this existing propane, which I've started to disassemble. But that size 22K needs 3/4. So all this ½ inch is a no-go. It's just really to be able to meet the loads. If the generator's fully loaded to 22 kilowatts, it'll need 3/4. Basically 3/4 is going to do all those generators. So 3/4 is a safe bet. This is the propane main feed for the house. It's going to be more or less the same as natural gas. It's coming from this tank over here, and basically that tank comes up and has a regulator. So before this regulator, this is all high pressure. It goes to this regulator. That's all going to be low pressure. That then goes into the ground, goes under the concrete, stubs up. So that's the real main reason I'm putting it on this side of the house. The electrical panel is 100 feet away. So the wiring is going to be a pain, but I'd rather run wiring than try to go up through the attic and be punching big propane black iron pipe. So for convenience reason, I'm putting it in proximity with the available propane lines. Here's kind of what I got. I'm going to repurpose the T that I had here. This was going this direction. It actually started as 3/4, then they had a step down right here. The step down 3/4 to ½ inch elbow. So this was like this. So I pull all this off. Now I've got 3/4 here. To turn this really easy, I just loosen the union and then hold the pipe going in through the stucco, turn the Y or the T. And so right now I'm just doing some puzzle piece kind of fitting. So I'm going to get tight to that corner. I'm going to just barely clear that conduit. I'm going to run it. It's 11 feet. So I did actually a long time ago in another video, I bought some 1-inch pipe for a handrail for that construction over there. And I cut it and thread it and stuff. This time, but I did borrow those tools from a friend. This time I think I'm going to get pretty lucky. I think I'm going to use a 10-foot stick, a union, and a 1-foot and then an elbow, and then I'm gonna actually have to break a little bit of this pilaster or baluster or whatever, a little bit of this block right here to get this corner. So playing around with that, a lot of just predicting the measurements and then doing a lot of test fitting. And then when I round the corner, I'm gonna bring it out, clear this conduit, and then basically it has to go to a flex hose. So the generator's gonna vibrate and everything. So this is the flex hose. It's actually loose. So I could unthread it, and I guess I will, just to show you. So this is where I'll have to be making my connection. It goes right in here. When you take the generator apart, it's pretty easy to see. So for each of these connections, I'm gonna do two things. On the threads, I'm going to put a little bit of the liquid Teflon. Make sure you get one that's for gas. And it does show this somewhere, right on here. It's propane. There's a bunch of stuff in there. And then the other thing is, this is propane or natural gas specific Teflon tape. So I'm just doing a light coating, and then I'm wrapping the same direction as the threads. So if you think about it, if a union was going to thread on this way, I'm going to start the Teflon tape and thread it the same way that a union would thread on. And then I'm just going to build it piece by piece, piece by piece. Right now I added a union, so I'm actually building it piece by piece, and then I'm basically going to build it piece by piece, but I won't, it's so hard to assemble up against the wall that I got the union, so I just kind of slid it off. I know what I need to do here. I've got to do a close nipple, an elbow. Now we'll do it from here. The union, a close nipple, an elbow, and then this 10-foot stick. So I'm going to assemble those, kind of mock them up into place, and I'm still actually working on how I'm going to fasten it to the wall. I did get straps like these, but I realized because I have to cross over the existing EMT, I'm going to stand it off from the wall a little bit. So figuring it, but here's the current situation. Alright, so for sure this is the tougher part of the generator install. So here's the transfer switch. Basically, what's going to happen is there's going to be two big lines, 200 amp service, so that's a 3/0 copper going to the top. So what I did was I added that, and then we're going to have the generator wires coming in, coming over to the side, coming to the bottom, hooking up down here on the E1, E2, and then also 6 wires right here. So I've brought them through that center. So just to mount that, it's a mess, you know, big stucco cuts, drilling up into the eave, inside into the attic, and then of course hanging the thing. And then that's still not done. The next bigger problem is basically we're gonna follow the power flow. Power comes in this big 3-inch, and it comes up, and it basically goes to the meter. Then it comes out of the meter on these wires up here, these black ones, which are live. And then it goes to the breaker. And then from the breaker, it goes to these two little bus bars, and you can see they feed the whole bus. So basically what the purpose of this transfer switch is to intercept that. So the most probable way, I'm not supposed to go in here. I didn't know that at first, actually. I thought this was going to be really easy. I was going to tap onto some things, and I was going to pull them over here and mount the transfer switch here. Once I realized I couldn't do that, what I determined I would do, I'd take these two bus bars out, and basically I'm going to put lugs onto those two, bring those wires tightly up. And this was the problem right here. I had these big Polarises right under here, and those were just too chunky, so I just pulled all that out. I got a hydraulic crimper, which is in this blue case, and I just did a hydraulic crimp under here. I could slide it back. It's live, but you can check it out. See those big crimps? So that heat shrink I haven't shrunk yet. So I did those big crimps, boom, and that's gonna just free up a little bit of room, but it's still gonna be tough. So I gotta bring those two 3/0 wires up like this. I cleared a little bit out on the top, but I couldn't really clear that much. So I'm gonna, that white pipe, that white piece right there is actually just some PEX pipe that I was using for like a, fish some wires through. So I shoved that through. I can fit the 3/0 in there with that big cable. So two are gonna go up into the attic through the top plate, over, back down, and bang, they're gonna land right there. That's gonna suck. And then the other two, right, so the power will go here. Then the other two, basically, they will come out here, gonna drop through the box, gonna put in a gutter. So I got a gutter. Drop them into the gutter, bring them over, put them through this LB, tuck it up and under. The LB on the backside has the panel, so I'm gonna actually cut a hole in the drywall inside my house. And then also the ground and neutral, because they're bonded in this main panel, both of those are going to come through the LB into the gutter up, and then they're going to land in here, and I'm going to unbond these because this is going to be essentially more of a sub panel. So the first point of disconnect is going to be this main breaker. It's kind of weird, but if you think about it, that is first, so this is the main panel. And then this was the jam. There was, I had this thing stuffed full of stuff, so I've eliminated a couple breakers. I've eliminated a bunch of breakers down here just to get room so I can fight those 3/0 wires down in and fight the 3/0 wires up. So to do that, what I did was I added this sub panel right here. This is not a critical loads. This is just a regular straight sub panel. This generator setup is going to back up 100% of all loads. It's the only way I would do it. I'm not really looking to goof around. So, with that sub panel there, the best way I could see was to put this junction box, and then I had all these conduit coming up and tucking up into the wall, and then this whole big janky board kind of cabinet swing thing was built in. Not me, years ago. It's always bothered me. So I took all the exterior conduit, cut them all off, put the male adapters, I just glued those right now, and then I'm going to drill holes in this box. I'm going to land all those coming into the box, do any sort of junctions that I have to do, splice the wires or whatever, and then they're going to go out into this 1.5 inch, 1.25 inch, whatever size that is, and then tuck up in there, and then that will basically be my sub panel for all my outside stuff. Now if I want to add something outside, I'm not going to bust the stucco again. I'm not going to try to come in here. I'm not going to try to do nothing. I'm going to land it in that panel. So I ran number 4 copper, so it's like 90 or 95 amps. So I got more than enough power there to add a couple things or whatever. So it's taken quite a bit of planning, actually. And of course, to do any of this work, I power down. So like, I make a plan, I talk with my wife and in-laws, and I say, hey, I'm gonna take the power down, and I just try to slam stuff out and then get the power back on. It's summer, it's like 90 something degrees, so I take the power down, nobody's happy. So this is the current setup. I'm pretty beat, and this stuff kind of sucks, to be honest with you, but it's going to be sweet when it's done, and then I can totally stucco all this back up. I'm going to have to paper it and lath it and get it all nice, but I want to close this up and get it nice, get it all clean looking, and also keep any rodents and wildlife and stuff out. So come along. Definitely a pain in the butt job. So where I'm currently at, I pulled all the junk off the bottom, I cut it, I ran all these conduits into this junction box, I brought those wires through this 1.25 inch conduit, I got that sub panel hooked up, I put in that LB, I'll get a close up in a second, comes down, comes this way into this gutter, and then I put in that EMT rain tight up into the box. So let's take a little bit of a closer look, and I'm really trying to get this so I can stucco all that closed. So you can see it's a lot more accessible to get at those lugs, and it's a lot more accessible to bring the big wires down into that LB right there. So with this LB, to try to get the depth right, because I do want that gutter to be up against the wall, you know what, let me prop this open. Everything is still live, so. There we go. Alright, so I did use a service entrance LB, which is a little smaller, lower profile. It's going to be tougher to get the wires through, but you know what? Having to face it that way, the actual access is not accessible, so I'm going to put a hole inside in this room that's right inside that drywall, so I can land the two on the lugs, bring them down, stick them in, sweep them out into the room, pull enough in, turn them back around, shove them out into the gutter, pull them out, pull it this way, and then tuck them up and in and over to here and into there. So it's still gonna be a wrestling match for sure for that 3/0. It's got to do the two 3/0 wires and one 1/0 neutral and one number 6 ground. So it's gonna be fun. And then because I've got this upper a little more accessible and I cut an access to that big connector right there, I'm going to shove the other two 3/0 wires up and over, and they'll come out right there. So I've got it mostly laid out. I might do a little bit more tweaks. This box, I could probably put a cover on it, but I'm not going to anchor it because I do want a stucco wall behind this and get it all nice. The other thing I have to do is I'm going to take this apart and eliminate this. This was just jumping over here to power my sprinkler boxes. You can see it was right there. So I took that off. I'm going to land an outlet up here. I just have it wired for temporarily. I'm going to bring some flex down here and get the outlet down here in this area closer to the boxes, and then that'll just leave my telephone box that was here I don't really use, but I'm not going to eliminate that. There's just no real reason to. So this job's a real pain, I'm gonna tell you. And this one, you know, we'll call this a rough draft. I've got it wired. 1 second. This one's kind of a pain to get open. So, you know, I got some bare essentials there. I've got that number 4 copper coming in, good for about the 95 amps, and I'm feeding that off of an 80. So it's more than enough for the outdoor items. Pool, pond, a couple outdoor outlets, a couple more outdoor outlets. So that one's good. Clears up all that junk down there. I'm not going to close that up all the way. So it's coming along. And then so this stuff I've been just doing solo. I'm going to bring my electrician friend over, and we're going to pull the generator wires. We're going to pull the auto transfer wires from the main lugs, and then we're going to pull the main lug transfer wires out and over. Bought that hydraulic crimper, and I practiced making a couple lugs right here, crimping them on. I think they turned out sweet myself. So that's gonna definitely help with the space, the tight space, rather than using the set screw style. These things are just chunky. So it's still gonna suck. It's gonna be smooth sailing, but obviously to do that work I gotta take the power down to the house, and then if I get in a jam, I got no power, I'd rather make a deal with him and have him here so we can slam it out. Maybe we'll do it in 2 hours, maybe it'll be 4 hours. I don't think it'll be closer to 8 hours, but at least I'll have the power back on a reasonable amount of time. So this concludes for now. Spray foam party. So that's cut 2 cans of the great stuff. Packed all those corners. I got a little cleanup to do, obviously. Packed all this in there. Now that I got my wires where they need to be, I relocated the ground, which means over here it's got the ground rod, but it's also got a UFR right here that goes into the foundation rebar. So I disconnect, because there was a cabinet here, we had kind of run it across the surface, so I drilled a hole in that stud, disconnected it, fished it out, fished it all the way back in through the holes in the stud rather than on the surface of the stud. So that way this foam will be hardened up and expanded a little bit more tomorrow. Anything that comes out too far, I'll shave off, and then I'm going to tar paper this. But I decided, you know, the problem is to really attach the tar paper, I'd have to get onto the stud, and they only cut the stucco to the stud way back in the day when they did this. So I got the fortiflash, which is a very thick tape. It's a lot more money than the tar paper, but this one roll will easily do this job. So tomorrow morning I'm gonna flash it and then lath it. The lath, I'll be able to catch the side of the stud here just so it's strong, and then I'm gonna have the stucco patch done so that way when I mount the gutter it'll be sweet. So this stuff's all loose right here. As you can see, we'll be able to pry it out and get the stucco. I'm going to shave this and kind of clean this up. That corner got cut at some point. It really should look like that. I might try to shape it a little, but if not, I'll just do a straight cut. Better than what I got. So, really trying to, A, efficiency, and B, mouse-proof this. We got a lot of mice around here. Alright, as you can see, the spray foam is dried, and I just flashed it with the fortiflash. I really like this stuff. It's I used it for the stucco patch in the past when we did this main panel right here, and it was really good. So it's pretty easy to use. Unroll it, you know, pretty much attach it. Like for example, this box, you know, I went right up to the flange. I brought it over here as far as I could, up against the edge of the stucco and the studs. I would like to have tucked it behind the stucco, but I'm pretty good with this. And similar all the way around over the tops of the flanges of the box and the outlet. And then around this one little conduit that comes in and right up against the weep screed for the stucco. And then what I'm going to do as an extra precaution, I'm going to run just a little bead of silicone right here. You know, in any of this. Is it necessary? Maybe not. But the thing is, stucco is pretty porous. Even though the stucco's painted, it's still going to be somewhat porous. So if the water pulls through the stucco, it should come in and hit the paper. And obviously this paper was cut previously, kind of sloppy by the way. So if the paper is gone, technically the water could seep right through the stucco and into the insulation and be inside in your framing and drywall. So it's all flashed. Water is going to hit this and run down. So I'm just basically going to have stucco right here. It's going to have to be a little high because the pipe for the main, the conduit for the main's out a little. So it'll be a little rough right here, but it'll turn out sweet. And then I'm going to trim this, get this clean. You can see the scraps got to clean up, and then I have to attach this lath, expanded metal, and that's going to basically be when they do the stucco is going to get pushed into the lath. So the lath has to actually be anchored to the studs, so that way the lath doesn't pull. So I'm going to shoot some screws, lath it up, and then I'm going to be ready for the stucco patch. Time for an update. It's been probably about a week since my last generator video. Had a few more things to do. So I didn't work on it all that much, but I am close to being done. I had some help. We a couple of electrician friends, dad and son, and we slammed out a lot of stuff, but not quite done. So we pulled these wires. These will become the new service feed for this whole panel. Basically, it got a little complicated because to try to land these up here, this is live by the way, where I originally thought, it just gets too packed. It's just extremely crowded in this area. So we kind of walked away from that idea and decided if we did a nice, if we brought them in the bottom, we could do, there's a lug that we're going to attach that's going to convert it basically to a bottom feed. That's good for 225 amps, or at least 200. So that's going to be a pretty good fix. This panel's done. That box is all sealed up. The stucco that was busted out, to put in the LB and run the stuff down into this gutter. It's all sealed up. You can see these wires here. You can see the EMT is attached. Everything's permanently mounted. It's basically wired minus these. So let me explain. Essentially, what we've got here is the power comes into the meter. It comes over to this breaker. It's going to drop down. These two lugs are going to get swept this way and attached to these two wires. That's why these are hanging here. Obviously way beyond extra long. But these wires are going to get, put a nice bend, land one here. On the outside one, put a little bit of a sharper bend and bring it up at an angle. So you can imagine if that's got a sweeping angle, it's just going to be really tight to these lower ones. And that's why we decided to eliminate those bars. So we would have had this done last week, but after really discussing, it's not worth being that close and potentially making a short. So that's kind of the plan. So these wires are hanging for now. So it'll go into the two. The two already run up through the wall, and the two come down, and they land on the utility source connections. Boom. And those are done, and they're permanently in. I used a little bit of the special grease because they're copper, and the mounting block was aluminum, the anti-oxidation grease. So those will come in, and then assuming that there's power, they'll drop down to not to these two, to the behind the bigger ones, and those are the T1 and T2. So those T1 and T2 are also the 3/0, so they're 200 amp rated, and those ones are the ones that come down, go through the gutter, come up through this LB right here. So these will now attach to the bus. So this whole entire bus will basically, it's kind of funny, it's not going to be a top fed bus anymore. It's going to come to here, sweep up here, travel through, come back down to the bottom. Boom. And then that'll become a bottom fed bus. Looking back, the Eaton panel was recommended by another friend for the reason of these bus bars are not that difficult to disconnect, but it's just too tight right here. And I looked at some other panels, and I think Eaton was a horrible panel to put in. And I just put this panel in 2 years ago, and I'm already really struggling with it. In my ignorance, I thought, an Eaton will be really good because look, you can undo those two wires and really easily just pull from the top, and then basically this is, you can't really tap into those wires effectively. That's just not the way to do it. It's kind of a mess. And we can't open up this side. This is the electrical company side. So bad panel for this job. But once that's done, this job will be done. So the other positive is right now, if the power goes out, and by the way, this neutral and this ground, smaller ground, that's all we needed to run was a 6, also come through the gutter, and they land here. So this is bonded, and this is not bonded. And the logic is, because this is the first disconnect, this is still the main panel, and then this is essentially more of a sub panel than everything. So these neutrals and grounds are bonded here, and these are separated. And as not being an electrician, a little unfamiliar with that concept, but in discussing it with my electrician friends, this was the way we proceeded. So that stuff's all good. Now when the power goes off, basically what's going to happen is these utility connections will become disconnected through this transfer solenoid, this mechanism right here. Boom, that disconnects, and then what happens is these two, the ones we're looking at, E1 and E2, will then be connected to T1 and T2, and these actually come from the generator. So if you look, these two go up and into here, And they go all the way up and all the way through the house, 125 feet. So those come from the generator, and they also come with this ground right here, and they also have like the this neutral is from there. So pause that for 1 second. Let's go follow these wires. I'm not taking any attic. Follow these wires to where they come from. All right, so it's a bit of a walk here, and I have to say, those wires were not a whole lot of fun. They definitely were not. And also, I ran those 1/0 wires, so they're good for 1/0 aluminum is good for over 100 amps. But what I can't come to find out was I got a pretty good deal on those. They were actually 3-phase wires and had a steel cable in them. Those were so hard to move and maneuver. So they go all through the house, all through the attic. They come out in the garage over here. That didn't work. All right, let's check it out. Come out in the attic over there, go into this flex. Flex does a couple bends, comes through here, goes into this closet, and then outside. So it's a whole, pulling those wires through the house was really difficult. And then here's the leftover. But I'm telling you, like, I wouldn't consider myself a weak person, but like, it takes a lot of force to get it to do even just that bend. Way harder than normal. And what I came to find out was these 3-phase wires actually have on the ground, these are all aluminum strands, except for this one right here where my thumb is. Let me spread it a little. This one's actually got a steel cable for like strength, I think really for pulling strength. So part of the job was my fault for not getting your like basic like south wire, or some typical brand. That right there is a steel wire, and that sucker makes it hard to bend, very hard to bend. So to the generator. Alright, so check this out. I just roughly put this panel on. Let me probably back off. Alright, there's the business end of things. So those couple wires that go to the transfer switch come from here. This is more like, the 2 hots, right? 1 and 2. One is black, one is I made red with the tape. The neutral comes from here, and the ground lands down there. And that's basically when the power goes out, this generator will start up and it'll put its 120 and 120 volts right here, and that becomes your 240. And then this neutral becomes it's going to disconnect. When it disconnects from the grid, this will be neutral, so everything will still have a neutral in the house. It's kind of a little bit weird. And then the ground is grounded everywhere, so this is really just grounding the equipment. It's not like this becomes the source of the ground. It still would use the grounding rod. So that wire size was way overkill. This really could have just been a 6 wire, but the cable I got came with that ground, so I didn't want to separate them. And wire's expensive right now. That wire would have cost me $1,500. So I found a guy on like OfferUp or something for $350 for these cables. So it was a super good deal, but it did end up being a pain in my butt. So that's the main wiring to the generator. So basically these 4 wires. For the amperage I'm running in aluminum, I needed 1/0, 1/0, 1/0. The ground could have been smaller. If it was copper, it would have been like number one, and then 6 or so smaller. Copper would have been even more money. So like here in Southern California, that would have been over $2,000 today. Build back better plan. The other wires, check these out. So there's 3 wires here, and these are basically my DC wires. And then there's 3 wires back there, yellow, orange, and blue. And then right here, the black, red, and brown. These 6 wires also have to be run between the generator and the transfer switch, which means I had to run those 125 feet as well. These are smaller. These are 18 gauge. That's what it called for. So those are all landed and everything. The ground is for the 12-volt battery, the whole 12-volt system. As you can see, did put a battery in there. And then the positive basically is just going to charge the battery. And then the transfer is the signaling voltage that once the power goes out, and this is going to get a signal, and then it's going to start, and then it's going to send a signal to actually throw the transfer switch. And then up here we've got these couple wires are going to sense that the utility dropped out, and they're going to signal the generator to begin to start and get ready to do the transfer on the transfer switch. And then that blue one in there is just your basic 120 volt. That's going to do a few things. This has a couple different things that it needs to do. Like it can power its own onboard charger, and it does have regular AC voltage to it for some of the equipment. So those 6 wires, not really a big thing. Just figure you're gonna pull 6 small wires, 18 gauge, and some big wires, 2 hots, a neutral, and a ground. Size them as needed, and then those go up through this non-metallic flex into the LB, into the flex, into the attic, which then changes over to it's got EMT, goes all the way through one side of the attic, and then I changed it back over to a non-metallic flex, brought it all the way over there. Let's take one more look on the other side. So honestly, this job should have been a lot easier for a normal layout. It's just, well, with my propane being over there, and I'm not looking to add another big propane tank, and I'm not going to trench all over the place and cut concrete. This is my propane now. Propane comes here, so boom, I added that pipe. So that's my propane source, and then my panel being on the opposite side of the house on the propane is what really complicated it and made it a lot more expensive for this particular application. See, a lot of people doing the Generacs don't have these challenges. They're doing like a pretty short little run, and a lot of times the meter socket's its own box, so it's really easy to pull off the meter socket. That combination main panel meter assembly that's flush, or at least semi-flush in the wall, that made this job really hard. It really did. So I'm kind of sick of this job, to be honest with you. I'm happy that I'm going to have backup power, but this is a big pain in my butt. So again, check these out one more time. These are the wires from the generator right here. This big bundle, which is all dead right now. And then explaining neutral lands here. Ground kind of did a little loop around and lands there. Actually, no, this is the big ground from the generator. So the ground landed there, and then the 2 hots come down, and they're just here waiting for when the power goes out, at which point these 2 generator wires will be connected by the switchgear mechanism to these 2, which will then power the main panel, and everything that's on there will be powered. So no sub panel, no critical loads, no this is powered and this is not powered. Everything in this entire property is going to be backed up. Now that doesn't mean that 100 amps from the generator can necessarily support 3 ACs, a pond pump, a pool pump, 3 refrigerators, a freezer. So I might have to play around with the loads myself to make sure it can back it up, but I want to have control over that. So there's those small wires I was showing you on the other side. Remember the colors? This is where they land. So that's why they're here, and they just run all the way straight through. It's the wiring of this is very simple. The actual difficulty of installation, that's a little bit of a different story. So hope that helps. Okay, so here we go. Power's on. You can see the easiest way to see it. Pond pump's running. Yeah, now I'm gonna do a power off test, simulating a grid outage. Right, you see that it's coming in from the grid. Take the grid down. It's I'm watching the timer now.
I know what's next.
Yeah.
I gotta cook today.
Oh, see?
Yeah. Later.
I see.
Maybe hamburgers.
Okay, heard the generator start. Heard that big click. Just changed over the generator, and that was not even 30 seconds actually. That was about 20 seconds. The grid shows dead, and yet not ready. So we're running off. Now I'm gonna walk over, take a look at the generator. Real quick. Sounds a little funky. But it's running. I might have to look into that surging issue. I know it's got more than enough propane supply, but I may actually have to check the PSI of propane going into the generator itself. Maybe the pressure is a little too high, or maybe too low, but probably not too low. Okay, so let's say the power grid is restored. The generator will run for another minute, and then this is gonna transfer back over to the grid. So right now, power's coming in, going through this. There we go. Going back into the grid connections and out the grid connections, which come to this bottom fed breaker adapter. Then when the power goes out, there's no more voltage coming in here. Basically what happens is these generator wires become the source. These become disconnected, and it jumps it back into these T1 and T2, and those feed it. So we're changed over, we're back on the grid. So it's working, just gotta figure out why the generator sounds a little funny. Alright, probably gonna be hard to hear me, but I did figure out the surging. Pretty dumb mistake. So right there, that orange lever, I knew that was left for natural gas and right for propane, but I gave it a little push, and I thought it was already on liquid propane, and it wasn't. So I had it flipped to natural gas. So I pushed a little harder. I moved it to LP for liquid propane, and it's now it's obviously running perfect. So that was a good test run. I got a bunch of stuff to put together on it, but it did back up everything I needed to, and now I figured out why it sounded so horrible. So I'm gonna call it a success minus a huge cleanup.